I have no idea because Joan is her teacher. You know? So, I'd say she's going to get a different one.
A different what?
A different paper, because usually, like when I do it, I make a different paper. So, I'd say different paper. It's not too difficult, you know, like, I don't think the exam is that difficult. So I don't think the recit paper will be too difficult either.
Which recit?
None of your business, that's it. Okay. Oh yeah, you left your oh, she has your notebook.
Both.
Both, alright.
The whole one.
Right, so next page please, let's have a look here now. What happened to your plastic?
Was that plastic? No.
I don't have plastic on the front.
We got new plastic with chemistry books.
Even the previous one, there's no plastic.
Yes.
Oh yeah, I totally did. Oh well. Maybe next year I will. The quotient rule.
What's the maths thing?
Huh? All right. You can see okay? That's not bad. So last time we did the product rule.
What's the quotient?
Well, that's what we're going to do this time. So last time we did the... Did you try these questions at home?
Yes, I did.
Yeah.
Yeah?
Yeah.
Really?
Yes, I
Okay, I believe you. The product rule. So this time we will do the quotient rule, which you could probably guess, you know, if product was multiplying, what do you think we would do next? Divide. Yeah. So again, if you have something like EX over sine X, the derivative is not, what do you think I'm going to say?
EX over minus over plus X.
Yeah, it's not EX over cos X.
It's gonna be a formula.
Yep, just like last time, So there's going to be some formula here. And again, if you really want to show that it's not working like this, you can just do an example like, you know, for example, you could do y equals x. What's the derivative of x?
1.
Should be 1, shouldn't it?
Yeah.
Now I could change x into x squared over x. And the derivative here is not 2x over 1, because we should have gotten 1. So in other words, it's definitely not like this. There's going to be a formula. So quotient rule, we'll deal with problems like this. Okay? Will we start the formula part? Yeah. So, just like yesterday, or was it yesterday? Oh my goodness.
Very
Long.
good, yes, sir. No, yes, sir.
My goodness, the day's on
The last week.
Last week?
Yeah.
Good, okay. Today's only
The last
Tuesday.
Friday.
It's only Tuesday. It's terrible. Right, fx over gx.
And we already lost it.
It's terrible. Terrible. Okay, so to find the derivative here, well, we know the story. It's fx plus h, the function plus h.
Oh, that's delta y.
Only because I didn't make h0
No,
yet.
it's the-
Oh, it's a delta, yeah. Minus fx over gx all over h.
That's y of 4.
Oh, there's no 4 here.
The h.
All h is here. This?
No, the f. Yeah, x.
This?
Yeah.
That's a h. That's a
Oh,
h.
which angle?
H. 4. Totally different. Yeah. H and H. Alright. Now we need to simplify this. So, well, you want to bring it together first as one fraction, and we'll worry about that divide by h later. So putting these fractions together, you get gx plus h times gx. You know what, let me just make a bit more space. I'm just going to write it again, but bigger. And therefore better. Okay. Divide by h. Gx plus h gx. And here it'll be fx plus h gx. And then at the back, you have fx times gx plus h. So I left the space in the middle on purpose. I don't need to tell you this, but just in case, all I'm doing here is just putting the fractions together, AD minus BC. You know this one, don't you? You do. You're engineers. Yeah.
Like clever.
I didn't say that.
I said you're engineers.
Yeah,
Engineers being clever.
perhaps. Okay, so what I'm going to put in the middle here, I shall put in minus fx gx plus fx gx. Squish that in. And the reason for that, well, they both cancel, but the reason for that is, this is minus fx gx plus fx gx. What's in common between these two and these two?
After the GX.
No?
GX.
Just
GX.
gx.
Yeah.
Just gx.
GX, then.
So what I'll do is I'll take the gx out. And what am I left with? Fx plus h minus fx. Okay, and then here I'll take out the fx at the back, and what I'll be left with, I'll be left with gx plus h minus gx. And this is all divided by h as well, and of course the gx plus h and the gx. Now, let's just get straight to the answer. If I make h goes to 0, this piece here divided by h, what will it become?
Zero.
Oh my, not this
One.
again. Not this again.
Gy dx.
Of what?
F.
Yes. And then this here divided by h when h goes to 0, as h moves towards 0.
Zero.
You did that on purpose, didn't you? Yeah.
Gy dx or G.
Don't you have some rice to be burning? What is it going to be? KJ, thank you, tell me. The derivative of
G.
gx, yeah. So, and then what about here? When h goes to 0, what will this piece in red become?
Zero.
No. When h goes to 0,
Constant.
no.
GX.
Yes, thank you. Gx squared, because it'll be gx. Yeah. So here you'll get gx.
I have a question.
Yeah,
If it's going, it's not 0. It's
Correct.
towards 0.
Yeah.
Then why it's removed?
did you watch that lesson like I asked you to yesterday? Did you? Did you? No. So watch it and then you can ask me. All right. So you get this on the top, and then, as Yami said, on the bottom, you'll get gx squared.
It's blur on the left side.
Hmm?
Is that a minus sign?
It's just I don't have it here on the left. What's wrong? This is a minus here. Okay? So this is our result. That if y equals fx, or I'll just write f over g. If y equals f over g, then the derivative of this, it's the bottom squared, the bottom times the derivative of the top, minus the top times the derivative of the bottom. This is called the quotient rule. So it's how you can find the derivative when you divide. So that's the quotient rule. So if y equals f over g, then the derivative is found by using this formula. So bottom times derivative of the top minus top times derivative of the bottom, bottom squared. This is called the quotient rule. And you can use it to find derivatives of fractions, rational functions, division. Okay. So let's have a look at some examples. You got this?
Yeah, I got it.
Quotient rule? Okay, so let's return to the original question I had at the start. Y equals ex over sine x. So I always remember this rule as a sentence. So what you do, yeah, it's as follows. Listen carefully. Listen carefully. The bottom squared. The bottom times derivative of the top minus the top times derivative of the bottom. And that's the answer. You can take out the ex if you want. That's the answer. Yeah?
It doesn't matter if you go first. No, it's a minus sign. Doesn't matter.
Okay, another example?
Top first.
Not yet? Got that?
Just 15 seconds. Finish.
Oh, less than 15 seconds.
So not sure.
Yeah. Okay, here's another example. So, suppose we had, say, oh, I don't know, something like,
Log.
yeah, kind of like a log. Log x to the power of minus 1. So this is the quotient rule again, because you can change this into y equals 1 over log x. So it's a quotient, a division again. So you have here the bottom squared. The bottom times the derivative of the top minus the top, and what's the derivative of the bottom?
1 over x.
1 over x.
So it will be 0.
So it'll be minus 1 over x over log x squared. Or if you want, that's minus 1 over x log x squared. Yeah? We're good? No. I know we're not good. We are bad. We are engineers. Alright. You got that? Yeah? Okay. Okay. Now let's make it a little bit more difficult. So let's say we have something like y, well, yeah, I'm making it a bit more difficult now. X over EX sine X. Now why is this one more
Because
difficult?
to contextual and contextual.
We both. So which one first?
Multiplying is contextual is
Product or quotient? Quotient rule first. This is a fraction before it is a product, you know. So just be careful of the difference here. This is a fraction which has a product in the denominator. So here we need the. It's a,
That's a guy.
oh, do it. You need to buy glasses.
Yeah, sure.
That's
All right. This is a fraction before it is a product. So you have a numerator and a denominator, and the denominator happens to be a product. So compare that with, I don't know, something like this. So this is a product which has a fraction part. Okay, so this is a fraction which has a product part. This is a product which has a fraction part. Okay, I'll do that one more time. Now I think it's important because it's going to get more complicated in the next lesson. So this is a quotient that has a product as part of it, but this is a product which has a quotient as part of it. So is the first is this here a quotient which has a product as part of it, or is it a product which has a quotient as part of it? It's a quotient which has part of it as a product. Therefore, it's the quotient rule first. Okay? So everybody gets it wrong. And I think it's because they're thinking of multiplication before division in that elementary school rule there is it?
Division, multiplication, plus and minus.
What are you talking about? It's I forgot my. Yeah. Please, right there, it's already there, right. So, yeah, multiplication before division. Is that what you're thinking of? No, okay, good. What's wrong?
It is,
What's
it's like
difference?
something, you know, if in a one equation, if you have
Or
multiplication.
this?
Both
Oh, no.
months.
Never mind. Yes?
If you have like in one equation, multiplication, subtraction and plus, and we go in the sequence.
Yeah, division is still before multiplication anyway.
Yeah. Division, we go
What are you
one.
talking about? It goes brackets, parentheses, powers, multiplication, division, addition, and subtraction.
Both months.
That's what I wrote as well.
No, you wrote bomb das.
Bomb. I don't know that one. I know this one.
But the one that says Bodmas. PODMAS.
Then I wrote it too fast. It's this one for sure. Okay, this is the one I can remember because it's the American one. Please excuse my dear Aunt Sally.
Please.
Now forget about that one.
B is brackets.
Right.
Yes.
B.
OGMAS.
Is this what I wrote?
No.
You're saying this is what it is?
Yes.
Yeah.
No. It is not. It's BOMDAS, not BODMAS. BOMDAS. Brackets over multiplication, division, addition, and subtraction. The M is before the D. Who's your elementary school teacher?
Don't remember.
Who is it?
My teacher.
Who? Give me their name. I want to call them. I say, yo, dude.
We can provide address actually.
Right, anyways. So we are clear here that it is the quotient first. So we need the quotient rule first, okay? I tried to remember it, like I said.
Bodmas.
The heck? This is some weird Nigerian maths, okay? Don't be shocked with this.
No, it's not.
Sorry, this is some weird Nigerian
You can
Saudi
be wrong,
maths.
you know? You can be wrong. We can
Not in
all
this
be-
one.
We can all be right and you can be wrong.
There's PEMDAS and there's BODMAS.
Yeah, but they're please, PEMDAS is like this, yes?
Yes.
And the multiplication is before the division.
Yeah, but in BODMAS, division is before the multiplication.
But you realise how silly that is to have two different rules for the same thing, don't you?
We didn't make it.
BODMAS is here, we didn't make it.
Yeah.
Exactly.
So, if you know, this could be American, this could be British.
In seriousness though, KJ, seriously though, you're right, there are two different rules you can follow for doing these. But as far as I know, in the UK and Ireland and America, we use these,
Which?
both of these.
And in Nigeria?
And it would seem further east, perhaps, you would use this.
Because
No, wait, listen. Now, in fact, if you go into Google, you can actually get a picture of somebody who typed two things the same on two different calculators, but didn't get the same answer. They got different answers. And the reason they got different answers is because one calculator was using this, and one calculator was using this. So if you type in,
I remember.
you remember that picture?
Yep.
Yeah. So if you Google that, you can see it. The reason it's different is because of this. So anyways, the point is, here in Ireland, where you're living right now, and in the UK, we will use BOMDAS.
no, but when I was writing Cambridge, it was still BODMAS. And Cambridge is UK.
What key? I'm getting tired of this now. Right, well then in that case, in Ireland and America, we use BOMDAS. Alright?
You just added UK by yourself to make it strong.
What? Added what?
Like in Cambridge, it's the UK.
Yeah?
So we bought mass, we use there. So what you said in UK, you use PEMDAS.
Yeah, except in Cambridge it seems. Those weirdos there use something else. Alright, so the rule here is the bottom squared. So what would that be? That would be EX sine X squared. But we have to be very careful about the top. Let me just write that a little neater. So, for the top, what's the rule? It's the bottom times the derivative of the top. What's the derivative of the top?
0, 1.
Minus the top. And this is where you have to be careful because the derivative of the bottom is now a product. So in red is the derivative of the bottom. So now we need the product rule. So that's the derivative of the first one
E
times the second plus the first times
cos X.
derivative of the second.
Okay, makes more sense.
Yeah, you're not going to bod mass your way to success that way.
Can I do it? Explain it
I
again.
can do another one like it. Yeah. So just write that answer down. We'll do another one.
Do we have to leave it like at the beginning?
Usually for the exam, in fact, you can leave it like this. Praise the Lord. So yeah, you're happy with this news? Yes. Okay, can I go to the next one now? Yeah. Right, let's do another one like this. So let's say something like, let's make it a tiny bit tricky. We'll say EX over root X sine X. So before I start it, I will write it like this. EX x power a half sine X. Now I can start.
try this by ourselves.
Do you want to have a try first before I do it? And then I'll do it, yeah? Yeah?
Yes, please.
Yeah. So, the rule is, Carrara, we square the bottom first,
Okay, so now
So,
we start with
the bottom. So it's the bottom,
Have you started with quotient?
yes, again start with quotient. So it's the bottom squared.
Okay.
Then it's the bottom multiply the derivative of the top, which
So
is
it's
ES, minus the top
Oh,
times the derivative of the bottom, which is a
product.
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 So what's the product rule? First, the derivative of the first one, which will be a half x to the minus a half sine x, plus, and then we keep the first one the same, and then derivative of the second one.
Plus X.
Plus
Oh,
x.
it's easy.
Get the idea now? Yeah. This is normally the first question in the section section A, but the exam this year is different, so I don't think it'll be the first one anymore, but the point is still, I expect this to be a section A question.
Because you want to make.
No, I'm not making this one. I'm not making this one. Yes?
You know, you should make, like, you know how to, like, the pattern and thing, make, like, you know, you can practice that paper.
No, past papers. See, the only difference between this exam this year and last year is last year will include, this year will include everything, semester 1 and 2. So all you need to do to prepare for it is to do semester 1 exams from previous years. They will prepare you for the semester 1 topics, and then semester 2 exams from last year will prepare you for the semester 2 topics. Yeah. Okay. This is okay? Yes? Yeah. Let me just see what other types there are. I don't think there's much more other than those two.
Don't we do that because
No. Okay, let me just mark which ones to do. Can I mark them here? Right, so in number 1, oh yeah, sorry, before I do that, let me just do one more for you, an important one. So y equals tan x. Well, what does,
tan x is 1 over cosine x.
tan x is sine x
Over cosine.
over cos x. So we can use the quotient rule.
Yes.
So the quotient, what?
The derivative of tan
I
x.
know what the derivative is, you don't need to tell me.
No, I'm just
No,
asking.
no. Oh, then, okay, so
We
then,
did the same thing.
this is a question.
Yeah,
You want to, wait, so you want to know what the derivative of tan x is?
I'm saying, if the derivative of tan x. we
No,
know-
no, what, you said you had a question.
Yeah,
I have a question, or are you making a point?
No, I'm not making a point, I'm asking a question.
Right, so what is your question?
If we know the derivative already,
No, no,
so.
that's ridiculous, because I'm trying to find the derivative of tan x, right? So I'm trying to prove the answer to you.
Okay, so
Yeah.
you already know the answer, you just want to show.
Yeah, yeah. So stop ruining the magic, okay? Right, so the derivative here is the bottom squared, the bottom times derivative of the top minus the top times derivative of the bottom, which is another minus sine x. So this will be cos squared x plus sine squared x over cos squared x. What's cos squared plus sine squared? 1 over cos squared x.
Cos squared plus x sin x is 1.
Cos squared plus sine squared is 1, as you learned in semester 1. It hasn't changed
Voila.
in the trigonometry chapter. You forgot this?
Maybe.
Yeah, it's a problem. Right, let me mark the ones for you to do. So, 1a, b, L, and M. 1a, b, L, and M. And then in number 2, you could do A and B.
Which?
A and B.
B, A,
And
That's what I said. Yes. Note to self, I need to have more questions. There's no, yeah. Anyways, before you try those, let me give you your results. Sorry, can I close this?
Yep.
Yeah, can you put the light back on?